Hello. So let's review some. Let's do some revision about mm, about the mean uh, and standard deviations. So it's all begin with uh, measurement. So when you have measurement, uh, you don't want to measure only one time. Okay, it all always you want to measure few times, couple of times. So uh, you will know that whether your measurement is reliable or not. There are many theoretical explanation about why you have to repeat measurements, but that is not what is intended in this video. Okay, so practically, if let's consider a set of data. Okay, set of data from a measurement, and uh, this set of data with the value, we can call it random variable. So let's say your data, let's say random variable x. So x is our random variable. So let's say x from measurement. So x are 8. This is the first measurement, and then next you get 5, 14, 8, 12, 8, 10, 3, 13, 9, 7, 12, 9, 6, 10, 10, 6, 8, 11, and 7. So you have 20 data. So your number of measurement is 20. Okay. You see, some value of x appear more than one time. For example, number 8. Okay. Number 8 appear 4 times. So what? So first thing that we can do with the data is to find the sum. Okay. So this is easy. Okay. So you just sum everything up. Okay. So let's say 8 is your x1, 5 is x2, 14 is x3 until x20, which is 7. So sum use symbol sigma can be generalized by summation of your random variable x from I1 to n, and in this particular example n is 20. So you get your sum, because later on we will need to use the sum, and then mean. Okay, mean or average. And some textbook will specify not just mean but experimental mean. So experimental mean. So the random variable is x. So we use symbol x. So to express, to note that this is mean, we put a sub e here, okay, with a bar on the top. So it is the sum divided with total number of variable. So that is experimental mean. And now, okay, now there is a frequency distribution function. Okay, frequency distribution function. Sometimes it appears as probability density function. Okay, if yes, probability density function. Probability density function. In short, PDF. So it is symbol f, okay, and for particular x. So what is the likelihood for a given x? So that is the how many time the x appear or occur, so divided with the total number of measurement. So let's try number. Okay, in our data set we don't have 1, we don't have 2. Okay, we start with 3, right? So for f3, so it only appear 1. Okay, so it is 1 over 20 equal to 0.05, and then f4 none. Okay, so it's 0. f5 1, only 1. Okay, so that is 0.05 again. Same with f3. f6, there is 1 and 2. So 2 over 20, so that is 0.1. f7, do we have 7? Yes. 1, 2. Okay, so 0.1, and then f8. 1, 2, 3, 4. 4, 8. We have 4. Okay, 4 over 20. 0.2. f9, we have 1 and 2. Okay, 0.1. f10, 1, 2, 3. So it's 0.15. f11, we got 1 here. 0.05, F12, 1, 2. Okay, we have 2, so it's 0.1, F13, none, so it is 13 is none. Oh, no, we have 1. Okay, so it is 0.05, and then we still have, okay, we still have F14, that is 1, right? So 0.05, and then F15. No, we don't have. Okay, so means that the rest, okay, like for F x equal 2 also 0, 1 also 0, so the rest that is 0 is not, we don't have to calculate it. Okay, so how frequent, uh, what is the frequency, so you can ask question, what is the frequency of getting x equal to 10? So it is 0.15, or what's the probability of getting 10? It is equal to 0.15. And so if you sum up the probability for variable x from 0 until the n, okay, it will always be 1. Okay, so total number of measurement of n, so everything was divided with n, which is the total number of measurements. We had we had defined the mean here, but there is another way to define mean, okay, by getting the first moment of the PDF. Okay. So the mean of x, okay, can be obtained by the first moment of the PDF. So that is x fe. X fe is the first moment of, first moment of the PDF. Okay, by the way, I forgot. Variable has two kinds. Discrete and continuous. And so far we deal with discrete variable. So this is for the discrete random variable. Okay, this one also for the discrete random variable. Discrete and continuous. Okay, next is residual. Residual. So what is a residual? It is how much the random variable differs from the experimental means. So for the first let's say the first data. Okay, the first data. So what is the residual of the first data, or the ith data? So that is xi minus the experimental mean. Okay, so this is residual. So why we need residual here? Because after this we will define the variance. Okay, that is residual, and then so far we define the mean as experimental mean. Okay, so that is experimental, and theoretically there is theoretical mean. Okay, theoretical mean that if you push your measurement towards infinity, right, and you using the same calculation here, you find the mean, and so that is the theoretical mean. So as it is called, it is theoretical mean. So in reality, that can never be achieved, but theoretically, uh, with the theoretical mean, you can define deviation. Okay, so deviation is like residual, okay, but uh, by differ from how much the data differ from the theoretical means. So theoretical mean, we don't put the sub e, it just x with bar. So and that symbol used is epsilon I. Okay, and so uh, uh, so we have defined deviation here. Okay, then we can next define variance. So variance is the means of deviations. Okay, so it's yes, it's the what is the average of uh, deviation of all data when by considering the true mean. Okay, true mean. So for the discrete random variable, so the average of so it is variance is the average of deviation, average of squared average of squared deviation. Sorry, it must be squared. Okay, it must be squared uh, because you always want the positive value. Okay, because there will be cases that your measured value will be smaller than true mean, which mean that the value of the deviation is negative. So use so the deviation is squared. So xi minus true mean squared. Okay, uh, I from 1 until n. Okay, divided with the total number of measurement. So the symbol is s square. Okay, s square, which is sorry about that. No. So the variance is the mean of squared deviation, right? So mean of squared deviation. Okay, so squared deviation mean. Okay, so it's mean of squared deviation, and the symbol is s square. Okay, so s square is variance. The definition of variance is the mean of squared deviation. So this is the square deviation divided with n. It become mean. And this can be mathematically proven. Okay, but when so the thing is we can never know the true mean. Okay, so we need to use the experimental mean. So when we dealing with the experiment, because we only it is always the case that we we only have the experimental mean. So instead of the true mean, okay, so then uh, the denominator, okay, instead of n, it is reduced to 1. Okay, the rest is a summation of deviation. Instead of deviation, it is summation of residual. So n from I from 1 until n, and then xi residual from the experimental value, and don't forget the square. Okay, this one, the residual. Okay, so when n is not that when n is small, okay, you have to use this one. But when n is sufficiently large, you can use you can regard your experimental mean as true mean, okay, and use the variance, and I can use the deviation instead of residual. So this residual, you can use the deviation, so you don't have to reduce n by subtract it by 1 with 1. Okay. This is so this is same equation with this one. So when your data is large, instead of residual, you can use deviation and apply the formula of the variance. Okay, and okay, because the definition of variance is the average of deviation. Okay, thus it is the, see, just now we define average. Not that one. Okay, we define average as the first moment of PDF. So the average of x, yes, first moment of x with the PDF. So similarly for the variance, since it is the average of deviation, so we can write it as the first moment of the deviation. So so average of deviation is the first moment of PDF. Okay, I think that was so we have experimental mean. We define PDF. for discrete random variable. So this example involve only the discrete random variable. And then first moment of PDF is the experimental mean. And then residual and deviation, and the definition of variance is the average of deviation. And if n is small, we have to, instead of consider deviation, we consider variance. And when n is sufficiently large, okay, theoretically it is valid to use the to calculate the variance by using deviation instead of residual. And variance is the average of deviation, so it is the first moment of the PDF with the squared deviations.